Welcome, class, to the Intro to Java Programming.
In this lesson, we will review abstraction, one of the major building blocks to object-oriented programming, along with how it works and some examples. Object-oriented programming is about creating objects that contain both data and methods. The four building blocks for object-oriented programming are encapsulation, inheritance, abstraction, and polymorphism. In this lesson, we'll focus on abstraction. Abstraction means using simple things to represent complex things. Abstraction is a process where you only show relevant data and hide unnecessary details of an object from the user. Yes, this definition is a little vague until you better understand the true meaning. Let's start with an example that covers an overview. Abstraction is about using simple things to represent complex things. My favorite example is the remote control for the television. You could use a simple power on, power off button found on the remote control. Behind the scenes, there's a complex communication process between the remote control and the television. Likely, many steps are involved and the television turns on. How the remote control and the television actually work is abstracted away or hidden. With abstraction, you no longer have a responsibility to know what those steps are and how they work. Simply clicking the button is the only thing you need to know. The remote control and the television will process the request. There is no command or keyword for abstraction. Abstraction is a concept, idea, or strategy you use when writing your code. Let me explain with an example from an adventure game. During the adventure, a player has a weapon and, inevitably, will be attacking a monster. The result of the attack could depend on several circumstances: the player's ability and skill settings, the player's weapon, any magical characteristics the player has, the monster's ability and skill, the monster's armor, and any magical characteristics the monster has. This all factors into the percentage odds the player has to hit the monster. If the player hits the monster, the amount of damage depends on the weapon used, any magical powers, and if the hit itself was a special hit. The attack will produce a number representing the amount of hit point damage done. There are other events that happen after the attack, like, was the monster killed? How much damage does the monster dish out to the player? Was the player killed? Is there any loot? For this example, we will only focus on the player attacking the monster one time. In the code, there will be a class that will start the attack process. Let's call this class the Game Control class. This class will know the player object, the monster object, and the weapon object to be used in the attack. There is another class called Attack Service, responsible for all the attacking code. There could be a method for determine the chance the player will hit the monster, determine the monster defensive adjustment for the player hit, does the player hit the monster, determine the damage done by the weapon used, and determine any bonus damage. Yes, the Game Control class could call each method to determine the result of the player attack. However, this would be a common mistake, typically made by junior-level developers. If you recall the example of the person using the remote control to turn on the television, with abstraction, you no longer have the responsibility to know what those steps are or how they work. Simply clicking the power on button is the only thing you need to know. Let the remote control and television process the request. The Game Control class should not have any knowledge of the details involved in the attack process. Correct, Han. Coach Joe rule number 6 states a class should only do one thing. If a class performs more than one action, this is known as a side effect and could be misleading to other developers. The Game Control class is controlling the flow of the game, not processing attacks. Calling all of those attack methods would indicate the class is doing more than one thing. Let me ask another question. What if the attack process added another method that somehow factors in weather? Say, a weather adjustment method used to determine the player's ability to hit the monster. Inside the attack service class, a new method could be added, but that also means a change is required in the Game Control class to call the new method. The Game Control class has too much knowledge of the inner workings of the attack service class. It's breaking rule number 6 and requires code changes when the attack service is changed. This is an ideal situation for abstraction. Instead of a remote control, we create an abstract method called attack. Let's put this attack method inside an interface called attack, and implement the attack method in the attack service class. The attack method will call all the needed methods to process the attack. In the Game Control class, the only line of code needed is to call the attack method. Now the Game Control class has no knowledge of the attack process. is doing one thing, and does not require a code change if the attack process is altered. This is abstraction. It is a concept, idea, or strategy used to make a simple thing represent a complex thing. The attack method is simple. The code in the attack service is complex. The game control class does not need to know how it works. That can be abstracted away. Just provide a simple method call that is easy as the power on button from the remote control. Yes, there can be many layers of abstraction. For example, in the attack process there was a method that determines the chance the player hits the monster. There could be several methods called from another class like these. Some methods from the attack service could be moved to the new class. The chance player hits method could call a simple calculate abstract method from an interface. This abstract method could be implemented by the player hit chance class where these 5 methods are called and processed. Again, the idea is to create a simple method call and abstract away the complexity. There can be many layers of abstraction as needed. Correct. Abstraction and encapsulation have similarities, but they're different. Abstraction solves issues at the design level. Encapsulation solves issues at the implementation level. Abstraction exposes a simple thing while hiding complex things. Encapsulation binds methods and properties into a single unit. With data hiding, some methods and properties can be exposed while others are hidden. Abstraction is done across multiple classes. Encapsulation is done inside one class. Let's look at the code for abstraction. Let's open the OOP Intro project in IntelliJ, close any open class tabs. Navigate to the test package or create a test package called Abstraction. Inside this package, let's create a new test class called Abstraction Test. This test will demonstrate abstracting the attack process shown earlier. Attack is the name of the interface. Attack monster is the variable used to represent a new attack service. Hit points damage will hold the value returned by the abstraction of the attack method. This line asserts the hit point damage will equal 8. Ignore these compiler errors for now. Let's navigate to or create a new Java package called Abstraction. Inside this abstraction package, let's create a new interface called Attack. There is one abstract method called Attack that returns an int. Let's create a new class called Attack Service. In the class declaration, use the keyword implements to use the attack interface. There are 2 private properties. There is one public method, the implementation of the attack abstract method. Here is the code used to determine the hit points of damage. Here are 7 private methods used in the attack process. Let's go back to the abstraction test class. Notice all the compiler errors are gone. Let's run this test. And it passes. This is where the abstraction starts. AttackMonster.attack is the simple call. Inside the attack service class, the attack method performs the complex work needed for the attack. This process is abstracted away from the test class. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of abstraction, a concept, idea, or strategy used to make a simple thing represent a complex thing. An example of an attack process was shown without abstraction. Although it works, many issues were identified. The same example was shown with abstraction that resolved those issues. Abstraction and encapsulation are similar when exposing simple, necessary things while hiding complex things. Some differences are, abstraction is at the design level and covers many classes, where encapsulation is at the implementation level and is done in one class. In the next lesson, we will discuss dynamic runtime polymorphism with method overriding.
Remember, future senior developers, make it work, prove it works, then make it better.
Ready? Break!